So basically this video will be start talking about the trig ratios. So basically in the first video, I've been talking about this chapter. Our goal is to find the trig ratios when the angle is greater than 90 degrees. So basically here are the three examples. So we have sine 135 degrees, cosine 225 degrees, and tangent 330 degrees. So basically, if you plug in these ratios in your calculator, you sometimes may got positive or negative values. So if you plug in these values in the calculator, it will got sine 135 degrees is a positive ratio, cosine 225 degrees is a negative ratio, and tangent 330 degrees is also a negative ratio. So in this chapter, you need to calculate this ratio by using the coordinate system. So, and also I will explain why we got negative ratio in some cases. Okay, so before talking about why sometimes we got the negative values of trig ratios, we need to refer to this diagram. So this diagram shows you the position of standard position angle. So standard position angle, we need to start rotating from positive x-axis, right? And it stops at the terminal arm. So terminal arm signals that the angle stops rotating at this position. And this point, we just call it x and y. So it's just random value, right? So what does x and y tells you about this right triangle here? So x actually tells me that the horizontal distance for this right triangle is a distance from origin to the positive x-axis endpoint here. So this one to this one, the distance is about x unit. So the y coordinate at this position tells me the vertical direction of this right triangle. So from positive x-axis to this endpoint, we just call it y unit, right? So we have x unit and y unit, and also the radius, we just call it r. So we have the new formula for trig ratios. Okay, so given that we have the right triangle in this position and the length adjacent is x, opposite is y, and we have the radius, right? So sine theta, it becomes opposite divided by radius. So originally we have equation opposite divided by hypotenuse, but at this time, we're going to replace it in x, y, and r. So we will replace the opposite by y, we replace the hypotenuse by radius. So sine theta equals y divided by r. So cosine theta, originally we have adjacent divided by hypotenuse, but this time we use x to replace adjacent side, right? And we use r to replace the hypotenuse. So tangent theta, we use y to replace opposite and x to replace adjacent. So this is a new formula you need to be familiar with. So I will be using these three formulas to show you why sometimes we got negative angles. So see you in the next video and you will know the reason why.